Yeah, so binomial is basically any term that has two things in it. So for example, if you have a plus b with the power 2, let's say, so that's a binomial because there's this thing and there's this thing and you're expanding them. Okay, so 1 plus 3x is a binomial. And if you put a power on that, that makes it a binomial expansion. Okay, so we should know how to expand it. For that, we have to learn about Pascal's triangle. Pascal's triangle gives us a really easy way to expand this thing. So here's how it goes. You write 1 and 1, then you write 1 again. On every side, you're going to write 1. But in the middle, you're going to add the two numbers. So 1 plus 1 gives us 2. Then you'll write 1 and 1 on the sides. This 1 and this 2, they add up to make 3. Similarly, this 2 and this 1, they add up to make 3. Similarly, in the next one, what will the numbers be?
4 and 4.
Then?
4.
4 and 6, because 3 and 3 add up to make 6. Kya ho gaya? And this one, it will be 4 again. And then you put 1 again. So on the either side, you're going to put 1, and in the middle, you're going to add them up. Okay? So that is how this number keeps on growing. This is called Pascal's triangle. Why is it called Pascal's triangle? Because these numbers are basically coefficients of expansion. Okay? How so? Do you remember this formula? If I have a plus b whole square, what will this equal to?
A square plus 2ab plus b square.
Very good. But if you notice, then this 2 is basically telling me that this is level 0, this is level 1, this is level 2, 3, 4, 5. And for level 2, the numbers are 1, 2, and 1, as you can see over here. Similarly,
Yes.
if I were to expand this a plus b power 3, these will be the numbers that I have. You can check it up easily. You can have a plus b and you can multiply them multiple times with each other. And you will end up with this, that you will have aq plus 3a square b plus 3ab square plus bq. And the numbers there are already 1, 3, 3, and 1. So that's how it goes and that's how it grows. You keep on adding these numbers and it keeps on adding more terms to this. Now, every number here is a term. So this is one term, this is a term, this is a term, this is a term. So there are 4 terms here. But you notice that the power is 3. When the power is 3, there are 4 terms. When the power is 2, there are 3 terms, right? That is because in binomial or in series, we start our counting from 0. So this is the 0th term, this is the first term, this is the second term, and that's how you get to 2. Now, how do we expand it? Basically, here's the general formula. You have a plus b power n. And by the way, Newton was the guy who discovered this. How do you make it up? You first put the coefficients here. Okay? These coefficients have a name. The first coefficient is basically you can think of it like this. N is the total number. Coefficient, what number of coefficient? 0. We want the 0th coefficient, right? For the first one. And then a to the power n and b to the power 0. You will see a pattern as it increases. So n coefficient 1, a to the power n minus 1, b to the power 1. All right. Similarly, n coefficient 2, a to the power n minus 2, b to the power 2. You keep on doing this until you get to b to the power n, a to the power 0, n to the coefficient n. Now, how is this working? If you notice, first of all, this n is common everywhere. Every term starts with this coefficient. Second, the numbers you can see are 1, 2, 3, it keeps on rising, but that same number appears here. And that same number is subtracted from this. So that is how it goes. So let me give you an example. Let's suppose I have a plus b power 2. So what will I do? I'll be like 2c0, the coefficient for 0, a to the power 2 minus 0, b to the power 0, plus 2 coefficient 1, a to the power 2 minus 1, b to the power 1, then 2 coefficient number 2, a to the power 2 minus 2, b to the power 2. If I simplify this, 2c0 comes out to be, these coefficients are basically from Pascal's triangle. Okay, this is the Pascal's triangle. So these will become 1, 2, and 1. Okay. Then a to the power 2 and b power 0 is 1. Similarly, a to the power 1, b to the power 1, and a to the power 0, b to the power 2. So this also goes away. So you're left with a squared plus 2ab plus b squared. Now, important
Sir,
pattern over here. Yes.
so जो 2c1 है coefficient
Yeah.
1, तो 1 coefficient है 2 power है.
No. 2c1 is a term. 2, when the power is 2, it's coefficient 1. When the power is 4, it's coefficient number 3. 4c3. Okay, it actually
So
has
मतलब कि 3
expanded
power 4 या 1
It's
power
not power. It's not power. There's another way of writing this. We can also write 2, 0. And this is equal to writing 2 coefficient 0.
How is 2c, how is 2 coefficient 1 2 and 2 coefficient 2 1?
Oh, you want to find out how we find this coefficient. These coefficients have a formula. Basically, here's how it goes. So let's suppose I have, you'll need to understand, yeah, all right. So Sameen's question was, how is 2c0 equal to 1? Like, how exactly do you get these numbers? So one easy way of understanding that is that if you look at the Pascal's triangle, then this is the term number 0, this is term number 1, and this is term number 2. And you can see that this is equal to 1, which is why 2c0 will be 1. And 2c1 will be 2, and 2c2 will be 1. Similarly, 3c0 will be 1, 3c1 will be 3, 3c2 will be 3, and 3c3 will be 1. Okay, so that's the basic answer that we might give to a 9th grader. But an actual answer that why exactly is this it is basically what exactly is C? So C is basically combination. C is telling me parts of something. So let's suppose I have NCR, then its formula is going to be n factorial over r factorial times n minus r factorial. Do you know what factorials are? Have you studied them?
Yes, sir, we have.
You have? Okay, that's great. So that means when I say 2c0, so what exactly I'm saying? I'm saying 2 factorial over 0 factorial into 2 minus 0 factorial. Now, what exactly is a factorial? What does it tell us? There is a lot of detail to that. But for now, it just suffices to know what exactly it is. So 2 factorial is basically 2 times 1. And 0 factorial is basically 0 factorial. And 2 minus 0 factorial is 2 factorial, which is again, आप इसको ऐसे कर लो. It is 2 factorial over 0 factorial into 2 factorial. And 2 factorial cancels with 2 factorial. You'll get 1 over 1. And that is 0 factorial. Why exactly 0 factorial 1? That's also a very simple question that we can answer after the class. Not really relevant to advance as of now. Okay. So that's how you get it. So when I say 2c1, I can either write it as this, or I can write it as this, or I can expand it and I'll be like, okay, 2 factorial over 1 factorial into 2 minus 1, which is again 1 factorial. So that gives me 2. Similarly, here's the thing. If I try to get 2c5, then that won't make any sense because 2c5 means how many partitions of 2? That's stupid. Like, so you can not have a negative answer here. So you can't be like, okay, 5 factorial over minus 3 factorial. Minus 3 factorial doesn't make sense. There's no number minus 3 factorial, which is why we cannot exceed this number here. So NCR and R has to be less than or equal to N, and it has to be greater than or equal to 0. None of these numbers can be negative. Okay. So that's just how we find these coefficients. So how do we expand it? If I have to find a general term, then A plus B power 5, let's say, then this will be 5C coefficient 0, A to the power 5, B to the power 0. Then 5 coefficient 1, A to the power 4, B to the power 1. Then 5 coefficient 2, A to the power 3, B to the power 2. Then 5 coefficient 3, A to the power 2, B to the power 1. And 5 coefficient 4, A to the power 1, B to the power, sorry, this must be 3. And 4, and then 5C5, A to the power 0, B to the power 5. Now, do you see a pattern here? What is the pattern when it comes to these numbers here? They are increasing, right? 0, 1, 2, 3, 4, 5, right? That's exactly how they're increasing. All right. What is the pattern in the powers of A? 5, 4, 3, 2, 1, 0. It's falling. What about the pattern of power of b? 0, 1, 2, 3, 4, 5. You can see that this is rising. So the second coefficient's power start to increase and the first coefficient's power start to decrease as you go on. What does not change is n, the power to which you are increasing it. That remains there. Like every time we have 5 here, we have 5 here. It's common in all of them because that is how we are expanding this thing. There are 5 power. That means there are 6 terms in total. The term number is 0, 1, 2, 3, 4, 5. And then the powers increase according to that. And that's how we do this. So there are basically 3 kinds of questions that the examiner asks you on this topic. Number 1, expand any pattern. Let's suppose you have 1 minus 3x powered 7. And the examiner is like, okay, expand this. So you'll be like, okay, sure. 7c0 is my first term. 1 to the power 7 minus 3x to the power 0 plus 7c1, 1 to the power 6 minus 3x to the power 1. Then 7c2, 1 to the power 5 minus 3x to the power 2. And that's how it will grow. Basically, ये power कम होती जाएगी, ये power increase होती जाएगी, and so will this number. Okay? That's one. They ask you to expand a term. They can give you a question like x power 7 minus 3 over x whole power 3. And they're like, okay, expand this. So no problem. We'll simply relate this as A and this as B. And then it's going to be 3c0, A to the power 3, B to the power 0, plus 3c1, A to the power 2, B to the power 1, plus 3c2, A to the power 1, B to the power 2, and then 3c3, A to the power 0, B to the power 3. And that's how you expand it. All right. So you will then obviously use some algebra. 3c0, you get the value. So this is going to become x power 21 plus 3c1 is 3, x power 14 times minus 3 over x plus 3c2 is 3 again, x power 7 because that's power 1 here into 9 over x squared. Remember that this is minus 3, so minus 3 squared is 9 plus 9 by the way. And this is 1, this is again 1, and that is minus 27 over x cubed. And you just expand it. So that's basic algebra. So you will end up with this being minus 9 x power 13 plus 27 x power 5 minus 27 over x power 3. So we expanded it, right? That's one thing that they ask you. And that's the easiest of the questions that they ask. Second question is they ask you for a general term. They ask you for maybe term number 3. Okay, so you're like, okay, I have the same thing, minus 3 over x, and I want to find term number 3. So term 3. That means, what is the power here? What is r? Remember this thing. This is term number 0, term number 1, right? But what is the value of r here? 0. Here the value is 1, here the value is 2, here's the value is 3. Okay. This is term number 2, this is term number 3, this is term number 4. When the term number is 1, CR is 0. When the term number is 2, it is 1. When the term number is 3, this is 2. And when the term number is 4, this is 3. So basically R, the general term is always 1 more than R. It is equal to the general formula, which is you take the power that you want to expand. You want to find the coefficient number R, okay? A to the power, the difference of n minus R, and b to the power r, and that is your general formula. That is also given in the exam sometimes, I think. And this is the general term formula. So let's suppose they ask you for term number 3. So what do? You take, okay, I have term number 3. That means r plus 1 is 3. So r is equal to 2. You take that. Okay, term number 3 means r is 2. So 3c2 a to the power 3 minus 2, b to the power 2. I'm using the general term formula. And that will give me whatever the answer is. Find 3c2 from calculator. This is what x power 7, that is what 9 over x squared, leaving me with 27 x power 5. So that's what I've got. Sometimes they ask you to just find the coefficient. So then you simply find the term and then you just keep the coefficient and not the power. Okay, so far, one kind of question is where they give you a pattern and they're like, okay, expand this. Second kind of question is where they tell you a pattern and they ask you for a specific term. They don't ask you to expand it all, they ask you for a specific term. And the third and most difficult kind of question that they ask in this scenario is when they don't give you R even. They don't give you the R, they give you something else. For example, they'll be like, find the term with x to the power minus 3. And you have to expand this same question, x power 7 minus 3 over x power 3. You have to expand it. Now you know what x to the power minus 3 is, but you don't know what is the value of R. Which term are we looking for? So then you use the general term formula to expand it. You're like, okay, I do know that the term I'm looking for is some number multiplied with x power minus 3. Okay. So that goes, you know, the formula is term number equals to Ncr a to the power n minus r and b to the power r. So right now you have been given this. You have been told that this is the term a to the power a into x to the power minus 3. What is a? It's just a random number that you don't really know what it is. On this side, what information do you have? You just plug that in. You know that n is 3. You do not know what r is. You do not know what you do know what a is. So a is this and b is this. So you know b is this. So you just plug anything that you have. Okay, so we don't know what r is. So we'll just do this 3c r x put to the 7th power 3 minus r and minus 3 over x to the power r. Now we use algebra. We are just comparing things, okay? So this becomes 3cr, remains as it is. This becomes 21 minus 3 minus 7r times minus 3 power r over x to the power r. Okay, we're just expanding it. We're trying our luck here. So I'm going to combine all the numbers and I'm going to combine all the variables. So this is 21 minus 7r minus r, right? Because x power r is dividing. So that will give me 3cr minus 3 to the power r, x to the power 21 minus 8r. Now, do you notice that I can compare them easily? I can see that, okay, here x to the power minus 3 and here x is to the power 21 minus 8. So I'll be like, okay, that means minus 3 is equal to 21 minus 8r. And I'll find r. So that will be minus 3 minus 21 is equal to minus 8r. So 24 over minus 8 is equal to r. That gives me r is equal to 3. Now I know what r is. I plug that back in there. This is just like substitution, okay? I plug it back in there. So my term becomes, my term number 4 now, because term r plus 1 hota hai. 3c3 minus 3 to the power 3, x to the power 21 minus 8 into 3. And that's how it goes. So 3c3 is 1, minus 3 is 27, and 1 over x power 3 ban jayega. And you're left with minus 27 over x cube, which is the answer that you're looking for. To save time, what we do is, instead of doing the whole thing, like this whole thing, we don't write this side. We're like, okay, we'll just do the other side. We'll find the value of power, and then we'll be able to find out, okay, what it is. So these are the 3 different kind of questions that they ask you in binomial. So for that, you have to understand that coefficients are given through expansion, through Pascal's triangle, or through calculators. The exact formula is NCR, which is this. You can write it in 2 different ways. 2, 0 means this 2C0. Either that, you can use this C symbol or you can use the vertical column symbol. Yes, Tanaya, what's your question? So Pascal's triangle is simply that you write 1, So you have 1 here, and any side must have 1. So no matter what level you go down to, it's going to be 1. These are different levels. This is level 0. This is level 1. This is level 2, 3, 4. So in red, I'm writing the levels. How do you write the numbers? You add the two numbers to write the number in the middle. Similarly, 1 plus 2 will give me 3. 2 plus 1 will give me 3 again. And obviously, we don't need the arrows. Similarly, here I'll get 4 because 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. The next level will be 1 here. 1 hamesha hai. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Yahan pe 1 aa jayega. Then 1 dobara aayega. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And yahan pe 1 aa jayega. So no matter what level you go down to, you can keep on going down to a level 100 or level 71 or whatever you want. You can just keep on doing this. Add the numbers, find the next number in the middle. That's one way. But the better way or the faster way is to use the Ncr formula. You want to find this term, let's say. This is on level 6 and it's the 4th term. So what will you write? You'll be like, okay, level 6. So 6C, term number 4, which means R is 3. R is always 1 less than the term number. And 6C3 is going to be 6 factorial over 6 minus 3 factorial into 3 factorial. And you can use that to figure out that, okay, it will be 20. But again, the factorial thing isn't really required for you to do. You have calculators. So you can simply use those. So we'll just do we'll do a couple of questions. So remember that there are 3 kinds of questions that the examiner asks you. First is that they give you a simple pattern. They're like, okay, expand this. Second is they give you a term number and they're like, okay, find that term number. And the third is when they give you a certain power and they don't give you what term number is. So you first find the term number, then you find the expansion. So I'm going to do this question with you. Hopefully, mushkil nahi hoga. First is find the first 3 terms in the expansion of this thing. All right. So let's just expand this. We have 2x minus 3 over x power 5. So we'll do, okay, 5 is n, c0, a to the power 5, b to the power 0, plus 5c1, coefficient number 1, 2x to the power 4, minus 3, which is b to the power 1, and 5c2, 2x to the power 3, b to the power 2. They keep on doing this. We are just required to find the first 3 terms. So we have done that. 5c0 is 1, 2x power 5 is 32x power 5, and minus 3 over x power 0 is 1. Okay, 5c1 is 5. This will become 16x4, and this will become minus 3 over x. 5c2. So 5c2 we use let's use this triangle. So 5c2 is going to be 10. So we'll just put it there. 5c2 is 10. So 10 into 8x cubed, 9 over x squared, and that's it. So what does this give me? 32x5 plus minus 240, minus 240 x to the power 3 plus 720 x to the power 1, and so on. And there you go. We have solved this. We have solved the first part, and this is worth 3 marks.
Is it 5c01?
5c0 is 1, but 2 power 5 is 32. That is why I wrote that. You notice it here?
Yes, yes.
2 power 5. Okay. Second question is a little tricky, but it's a very common question. And once you start solving it, you'll get the hang of it. They're like, okay, 1 over 2x power 2 is multiplied with this thing. And like, find the coefficient of x. That means we are looking for numbers that will multiply to give me powers of x only. अब जरा इसको गौर से देखो. This is this, And this thing is, of course, 32x power 5 minus 240x power 3 plus 720x power 1 plus whatever. I can easily multiply the whole thing and then figure out, okay, jo power 1 hai, I can take that out. That will be a really stupid way, honestly. What's a better way? A smarter way would be to think of when exactly will I get power 1. I'll get power 1 if I already have power 1. Or I'll get power 1 when something cancels out to give me power 1. Okay, when this multiplied with this, what power will we get? Don't multiply, just tell me what power will we get?
5.
5. So this is clearly not what we are looking for. When this multiplies with this, what power will we get?
3.
Not really what we're looking for. But when this multiplies with this, we'll get power 1. So that is it. That's the first term we are looking for. Okay, when this multiplies with this, what do we get?
Power 3.
Power 3. So we don't want that. When this multiplies with this, what power do we get?
1.
1. So that is what we are looking for, because the question says find the coefficient of just x power 1. So हम इसको इससे multiply करते हैं. We'll get 2 times minus 240 is going to be minus 480 x to the power 3 minus 2. So that is 1. कोई और है क्या इसको इससे करके आता है power 1? नहीं आता. Power minus 1 आता है ना? Right?
Yes.
So these are the only terms that will give us what we are looking for. And the coefficient is obviously when you subtract 720 and 480, what do you get? 140 if I'm not wrong. 240. Which part do you want me to explain again? Okay, here's the question. Find the first three terms in the expression of 2 plus ax to the power 5. They haven't told us what a is. लेकिन हमने उसे expand करना है. So 2 plus ax to the power 5. So we'll be like, okay, sure, 5 coefficient 0, a to the power 5, b to the power 0, plus 5 coefficient 1, a to the power 4, b to the power 1, 5 coefficient 2, 2 to the power 3, ax to the power 2, and so on. All right. That gives me 5 to 0 is 1. I won't write that. 2 power 5 is 32, and ax power 0 is 1. So I won't write it. 5c1 is 5. 2 power 4 is 16. Ax remains as it is. 5c2 is 10. 2 power 3 is 8. A squared x squared. That's what I get. So I'll end up with 32 plus 80ax plus 80a squared x squared plus so on. And we are done. We have found the first three terms. That's it. We are done with the first part. Second part. So what did I do in the first part? I just applied the binomial theorem. Binomial theorem says you take any term, you start decreasing the powers of a, you start increasing the powers of b, and then you keep on adding the coefficient. And there you go. It's simple. Next question is find the coefficient of x squared. That's the term I'm looking for. When you expand 1 plus 2x and 2 plus ax power 5. When you find x squared, turns out its coefficient is 240. That means I'm looking for 240x squared. That's what I'm going to get. That's my term that I'm looking for. But I do not know what number it is. लेकिन हमें कोई फर्क नहीं पड़ता. हम इसको expand करते हैं. हम देखेंगे कि x squared कौन सा आता है. Alright, so let's expand it. This becomes 2 plus ax. I've already expanded it. So this is what it becomes. 280 plus ax, 80a squared, x squared, and so on. Alright. अब देखें जी. When do I get x squared? If I multiply 1 with 32, do I get x squared? I don't. When I do it with this, I don't get x squared again. But when I do it 1 times this thing, I do get x squared. So I'll just multiply that. I'll be like, okay, 80a squared x squared. Good. Now, do I get x squared when I multiply this? I don't. So I'll just remove this. When I multiply this with this, of course I will. This becomes 160a x squared. And what happens if I multiply this with this? Do I get x squared? No, I get x cubed. So that's it. My work here is done. I'll just expand it, and they are telling us that this is equal to 240x squared. तो कर लेते हैं इसको. 160 plus 80 is 240a. Sorry, ये add ही नहीं होगा. It becomes 80a squared plus 160a is equal to 240. I just took away the x squared part क्योंकि वो common था. तो ये बन जाता है 80a squared plus 160a minus 240 is equal to 0. I take 80 as common, so that gives me a squared plus 2a minus 3 is equal to 0. And this, of course, shouldn't be a challenge for us. We'll just put it in a calculator or find Milton breaking or do quadratic formula. A number of different things that we can do with it to solve this.